Alrighty, let's look at this flashback review as we get ready for learning how to graph exponential expressions. The first question asks is, what is an x-intercept? This is where the graph crosses the x-axis. So if this was my graph, let's just say, and I had something that looked like this, my x-intercept would be these places where the graph is crossing the x-axis that goes left and right. And what is a y-intercept? A y-intercept is where the graph crosses the y-axis. And remember, that's the up and down axis. So if we have, this is our coordinate plane, and this is our graph, let's just say, the y-intercept is this point right here where the graph is crossing the y-axis. Sometimes there could be one, many, or no x or y-intercept. What is domain and range? Domain has to do with x. How much to the left and how much to the right does the graph go? Range has to do with y. How low to how high does the graph go? And remember that we might have to use square brackets if the point is included. And we use parentheses if it's not included. And how do we find increasing or decreasing? We look for the interval of x values where y is going up or down. Very nice. Alrighty. Now, I can graph and interpret key features of exponential functions. So the key features that we're going to be interpreting are domain, range, increasing, decreasing, and the intercepts. And then exponential functions, that's what we're going to learn how to do today. Graphing exponential functions. We are not able to use a slope and a y-intercept here because you're going to see that there is a exponent that's a variable and we don't know how to do that. So instead, we are going to type the function into our graphing calculator. We will then make a table on our paper. We are not going to use many values that have decimals. We might use like one or two just to make our graph form the shape. Then we will graph our points, and then we will connect the points and put arrows on our graph. So let's look at this question. On the set of axes below, draw the graph of y equals 2 raised to the x power. So I'm typing it in. I'm going to go to the table. I know we say not to use decimals, but here they tell us to use the interval -1 to 3, which means even if any of the numbers are decimals, we have to use those numbers that they told us. So -1 is 0.5, and that's going to be a closed circle. Then 1, they're actually all closed circles because they're all less than or equal to 2, 4, and 8. All right. -1, and then we're going to go to 0.5. 0, we're going to go up to 1. 2, we're going to go to 4. 1, 2, 3, 4. And 3, we're going to go to 8, 5, 6, 7, 8. And then we're going to connect these points. And we will not have any arrows since it's not going past there. It tells us to start at -1 and to end at 3. So that's it. All right. Now, this is our graph right here. But remember, ours doesn't actually look like that because we're starting at -1 and we're stopping at 1, 2, 3. So it doesn't actually look like that. It's stopping right here. All right. So, because we're going from -1 and we're stopping at 3. All right. So what is our domain? Our domain is starting at -1 and ending at 3. What is our range? Well, at -1, we're almost to 0, but we're not 0. And at 3, we are, what number are we at 3? 1, 2, 3, 4, 5, 6, 7, 8. We're right here. We're at 8. So we're stopping at 8. and the 8 point is included, so that would be a square bracket. What is our x-intercept? The point where it crosses the x-axis? It's never doing that, so none. What is our y-intercept? Our y-intercept is where we cross the y-axis, and we cross the y-axis here at y equals 1, which is the point 0, 1. Where are we increasing? We're increasing the whole entire time from -1 to 3. The whole graph is increasing. And are we decreasing? No, never. Will this graph ever intersect the x-axis? Justify your answer. No, it gets close to x equals 0, but never hits or crosses it. I meant to say y equals 0, because it never gets below 0. It never goes to the negatives on the y section. See, look, if you look at the y values, they'll get super, 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 super small, but they'll never actually hit 0, meaning we could never have an x-axis. All right, let's look at this next one. Graph the function y equals 2 raised to the x minus 7. So kind of what we just had, but now we're putting the minus 7 there. It doesn't tell us what numbers to use, so we get to choose our own. I'm just going to put a few ones with decimals, like easy decimals, so the -2 and -6.75, then -1, -6.5, 0 is -6, 1 is -5, 2 is -3, 3 is 1, 4 is 9, and that's going to be good for my length of my graph. So -2, and I'm going to go to -6.5. 1, 2, 3, 4, 5, 6, and we go a little bit more. Then that was -6.75. This is -6.5. Then -6, -5, 4, 3, -3. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Because they didn't tell me where to start or stop, I could put arrows on both sides. You will see that with exponential graphs, they form this little shape where it never ever hits that number. And what number is that? Let's see. This value is getting super, as we move the point, you could see it's going to go past -6. And then it's going to get super, super close to -7, but it's never ever going to hit -7. So, what is our domain here? Well, we're going to end up using all values of x. So we are -infinity to infinity. Our range, we are never going to hit that -7 point. We're going to get super close to it, but it's not included. So I'm putting parentheses -7. But we are going to go all the way up, so there will be an infinity. What is our x-intercept? Our x-intercept is right here. I don't know the exact number it is, but it's somewhere in between 2 and 3. So I'm just going to say between x equals 2 and 3, just because I don't want to guess a number. The y-intercept, that is definitely right here at -6. 0, because I didn't go left or right, and then -6. It's increasing the whole length of the graph, and we are never decreasing. All right, this question says, if g of x equals 1.5x minus 3, determine if f of x is greater than g of x when x equals 4. So what is f of 4? F of x is our graph. So at 4, what number did we have? At 4, we had 9. See here in our table, if you go to 4, we had 9. 9. Now, g of 4, the g equation is 1.5. Replace x with 4 minus 3. That would equal 3. So they want to know, is f of 4 greater than g of 4? Well, f of 4 is 9, and that is definitely greater than 3, so yes, that's true. All right, let's graph this next one. Graph y equals 3x, 3 raised to the x, over the interval that. So let's try it. I'm going to put some little decimals, but not many. Oh, well, I have to start at -1, and I have to end at 2. So -1, 0, 1, 2. -1 is 0.3 repeating. 0 is 1. 1 is 3, and 2 is 9. All right, -1, 0.3 is just a little bit over, and that's a closed circle. 0 is 1, 1 is 3, and 2 is 9. And let's connect them. We're not going to put any arrows since it tells us where to start and stop, and that is all. So we're starting at -1, and we're ending at 2, I think they said. Yes. So our graph should actually stop right here. Okay. -1 to 2. That's the whole graph that we care about. So our domain would be only the -1 to the 2. Our range at -1, we are 0.33333, so we're kind of close to 0, but 0 is not included. And then we're stopping at 2, which is 9, and 9 is actually included, so that's a square bracket. We never cross the x-axis, so that's none. Our y-axis, we did cross it right here, so our y-intercept would be 0, 1. We are increasing the whole length of the graph from x equals -1 to x equals 2, and we are never decreasing. And this was a Regents problem, but there was no follow-up second part question, so that is all. Let's look at some multiple choice questions. The graph of y equals mx passes through the point. So I put some examples here. If we had 1/2 x, where does it cross through the point? Does it cross through 1m? 1m? Oh, that looks like maybe it's true. Let me see for the next one. If my m is 2, am I crossing through the point 1, 2? That's true. And then over here, if my point's 3 raised to x, am I crossing through the point 1, 3? That is definitely true. The second answer choice was saying that it would be 0m. Well, that's already not true for the first one, because I would need to have 0, 1/2, and I don't have that. It's hard for me to check the next one, but let's look at number 4. M in the second one would be 2. Do I have the point 2, 1? No, I have the point 2, 4. So that's definitely not true. And we already found out that number 1 is definitely the answer. Remember, these tables wouldn't be given to you. I just did that to show you some examples of when m is 1/2, when m is 2, or when m is 3. All right. Another multiple choice question. The graph of y equals 2 raised to x, so I showed you a picture of it, intersects. Well, it's never ever going to cross the x-axis because it gets super close to it, so it's not that. And now let's see, does it cross the y-axis? It definitely does, so answer choice 2. All right, let's look at the next one. The graph of f of x equals 3 raised to the x lies in which quadrants? Remember, quadrants are labeled. This is the first, this is the second, the third, and the fourth. Well, it's definitely not in the fourth one, and it's also not in the third. It is in the first and the second. Good. And let's look at, that actually wraps up our lesson. We got practice graphing 3 of them. And then we also learned how to answer some key feature questions. Remember, these are what the x-intercept, y-intercept, domain, range, and increasing and decreasing is.